Hi, thank you for joining me for this talk about secure coding in the Python language. I should mention that there will be a breakout session after this talk, so feel free to join me and chat. I thought I'd start by talking about personal freedoms, personal freedoms as they pertain to my parenthood. This is Ethan. Ethan was born a little over a month ago. And when thinking of a middle name for Ethan, we thought we would pay homage to a piece of literature I really admire. And so we thought we would name him Ethan Droptable Students. And we thought this would really steer his humor in the right direction. Except then I took a look at the top 10 vulnerabilities and saw that injection is still right up there on top. And so this would mean every school or university that Ethan would go to, he would basically cause problems to the databases and to the computing systems and would probably be blamed for it. And so we decided to name him after my grandfather instead, Ethan Judah. And I also decided to spread awareness to the top 10 vulnerabilities so that perhaps Ethan could name his child with the middle name drop table students with little to no consequence. So when you look at these top 10 vulnerabilities, they rearrange themselves once every few years, and you see some making their way down the list, up the list. Once in a while, you see one out of the list, but for the most part, this list doesn't change much. And so, if I had to rename this talk, I would probably call it OWASP Top 10. Why are they still a thing? And I thought about this, and I think there are three main reasons. One is awesome developers are lazy, and a lot of times this is a good thing. Awesome developers are also very busy. We constantly need to move these features along. And finally, a lot of times we think of security as a person or a team's job, a specific person, as opposed to an ongoing collaboration between everybody in a company. And so, final title for this talk would probably be OWASP Top 10, Nudging Our Way to More Secure Software. A little bit about myself. My name is Ronnie Sheer. You can find me on LinkedIn or Twitter. At the moment, I head R&D at Hiverr, which is a brand new collaboration between Telrad and Team 8. We are in the field of BPO and education technology, bringing marketplace efficiency to school systems and to companies dealing with BPO. We really love what we do. We really love Python, and we are really hiring right now. So feel free to contact me if you want to talk about perhaps working at Hiverr. I'm also an instructor at LinkedIn Learning, and that means I've been selected to collaborate with LinkedIn in order to produce educational content, which is available to learning subscribers as well as premium members. So let's talk about keeping our applications secure from hackers as well as jerks. And I think maybe jerks are this new breed of hackers who are out to humiliate us publicly. Somebody who wants to publish something embarrassing about our company. And so the OWASP Top 10 is this document which details probably what is the consensus about the most critical vulnerabilities to applications. Every few years, it's modified. And the consensus is this is the starting point to securing your application. I highly recommend you checking it out. What's at number one? Injection. And this is where somebody named Bobby Droptables has deleted all the students from the school's database system. And it's not because his name is Bobby Droptable, it's because the school did not take the necessary precautions to protect themselves from injection. So, how does this happen? This is kind of an example which we probably know to avoid. We interpolate a username into a query, and that could actually take over the query and execute some problematic SQL in this case. Now, we all know this is a problem, right? We've heard of it, but for some reason it's still happening. Well, the Python documentation says do this, basically use the database API properly. But for some reason, it's still happening. I think the main reason is that we have direct interactions with the database cursor. What I mean is we've gotten to a point where we have these great ORMs that by default protect us from injection. If you use the Django ORM, you're protected. If you use SQL Alchemy, I believe, you're also protected. If you're not using an ORM, you can also wrap the database API with a protection layer. But what I wouldn't recommend is direct interaction with the database API because it allows this. So having a layer of protection above will mean that by default everyone's protected, and absent-mindedness or lack of awareness will not cause this to happen. There's also the issue of automatic checks, and this is something that I'm starting to really admire. The fact that we can incorporate things into our pre-commit hooks or CI systems, and they can catch these things even more efficiently sometimes than people can. And another added value is that when an automatic check happens, people's feelings are not as hurt. Let's take a look at what I mean by that. This is a great tool called Bandit. Bandit runs a static analysis of our code, and you can incorporate it into pre-commit or, your CI/CD. I highly encourage you to check it out. In this case, we run that vulnerable code through Bandit. When I start this, boom, I scroll up a bit, and I've been warned about a potential vector for SQL injection. This is wonderful. This means, less SOAR dynamics over problematic code reviews, meaning somebody's feelings are less likely to get hurt because, it's not a person that told you this, it's a machine. And also, it's going to do a pretty efficient job catching that. So there are a lot of vectors that can be caught by these static analysis tools, and I say go for it. Next up is broken authentication, and this could be kind of a big one, right? It's a broad vulnerability that could happen for a variety of reasons. I think a lot of times, though, an ambitious do-it-yourself user system could be the cause. Because user authentication is something that requires a lot of fine tuning. And so when people roll out their own auth system, often they don't update the password hashing systems. Often people don't hash passwords for some reason. And this is an issue. If you are DIYing it, of course, hash your passwords, know which algorithms to use. But I would argue that also we have this broad ecosystem of user authentication mechanisms that we can use these days. You can use a third-party authentication, you can use Django's authentication systems, and then by updating packages, you're constantly keeping up with best practices. Once you are using a built-in tool, you can fine tune it. You can prevent credential stuffing by not allowing people to constantly try new things. You can invalidate sessions after a short period of time so that on a public computer, somebody doesn't walk away from a computer, another person quickly steals their session. You can use MFA. And I guess this is a good time to mention with many of these vulnerabilities, I think we're at a point in time where there's no reason not to use SSL. Certificates are free these days. Yes, termination is a little bit more resource intensive, but who cares? What's the price of having this vulnerability? Anything that's on the web today should be SSL encrypted. Finally, there should probably be a good framework for experimenting during development, and I'll touch on that with other vulnerabilities. Next, there is sensitive data exposure, and I think this is the only vulnerability where one of the solutions is 100% foolproof. If you're not storing data, probably hackers can't steal that data. So it's a good idea to try to avoid storing sensitive data when you can in the first place. And if you are storing it, try to not retain it for longer than you need to. Of course, if you have no choice, use the necessary encryptions to keep the data safe. Another thing is make fake data readily available for developers and testers. In the absence of good fake data, testers and developers will probably use real data. This saves time. So if you allow developers to stay lazy and not use real production data, you're making it easy for people to keep things secure. And once again, always use SSL when possible. Another thing is using the right serialization mechanisms. When you have an API, sometimes it's hard to see what's exposed, especially when it's consumed by a single page application, for instance. Some serializer classes have a declarative or an explicit place where you can say, these are the fields I want exposed. And then it's really easy to keep an eye out on what's exposed and what's not. This is a good example for Django REST framework, a wonderful framework. And on a model serializer, you state these are the fields exposed. If you want to take it a step further, put some tests in place to make sure that only what you want is exposed. Next, there is XML external entities, and this is kind of a new one for me. It turns out that in addition for being horrible, verbose, and ugly, and a pretty inferior format, XML is also pretty vulnerable, or at least many of the parsers of XML are vulnerable to attacks. And so this basically means a parser might pull an additional resource, which would then crash the server. There's also all sorts of interesting ways of sending the parsers on these ongoing resource-intensive journeys. It's pretty enlightening, actually. And so the Python parser is actually vulnerable, and there's a drop-in replacement for it called diffuse XML, which you can use in an almost identical manner, which makes you safe as a consumer of an XML API. Now, why stop there? Why just diffuse XML when many of us can dissolve XML? And I'm talking about you people who can probably kill those legacy APIs and basically rid us from XML forever. So if you're in charge of an XML API, maybe this is the time to say, hey, let's go to a superior format like JSON. It's a little bit tough, but we are slowly working XML out of existence. And I'm sure in the comment section on YouTube, I'm going to hear some wonderful things about this, and it's going to provide for some fun discussion in the breakout session, which I'm not sure I'm ready for, but this is my opinion, and I guess I'll hear more later. Next, there's broken access control, and this happens a lot. A lot of times because we don't have time to deal with permissions right away. And so we use these utilities. This is kind of a utility that exists in various forms in different frameworks. Allow everyone, right? So we're putting together an API and we say everybody can see it because right now I'm trying to serialize and kind of I'm not worried about permissions at the time. But then allow everyone will eventually, by mistake, end up in production. Perhaps it's a good idea to create a context-aware allow everyone. So it's allow everyone debug, which if you're not in debug, will say, hey, exception, this can't be happening. Otherwise, if you're in development or other environments, it allows you to do this. This is very useful. There's a variety of utilities that you can create that allow people to mess around while in development, but will not allow this to move on to production. And this works. Unless you forget to set debug to false. Which brings us to a big one, security misconfiguration. So obviously, turn debug off in production. No matter what framework or tool you're using, Django has a very good checklist for deployment, which will help you with this. But a few things that can help you with security misconfiguration is, one, have a git ignore file right away using one of the well-designed templates you can find for Python and the frameworks that Python uses, and do it right away. Don't procrastinate because By procrastinating it, you can either forget it or have sensitive stuff in source control. So this is a big one. Learn your secret management tool right away. Another thing, not to procrastinate. It's not something that's easy to, make time for earlier on in the game, but why make time for it after you've been breached? It's one of those things where you just want to, as a team, decide to get into. Finally, provide a solid framework for experimentation. If you're having different setting files for different environments, that's great. You just don't want to make it so that the only way people can mess with settings is by changing things that can bleed out to production at the end. And this is in general true. Always have a place where people can safely try new things without messing up more stateful um, instances or environments. Next, there's cross-site scripting. And this is number 7, surprisingly. It is a huge vulnerability to have. It happens when untrusted, strings make their way into your system. So here we have a form, and basically, when it's posted, it sends back an interpolation with the favorite field from the form. So this is an application optimized for XSS. And let's see what happens when I run this. So here I basically have a wonderful site that says, hey, I love Python. What do you like? And here the attacker likes pasting malicious JavaScript into the field. And here it says, roses are red, violets are blue. I love C#, Java, and PHP too. Now, if this were persisted, there's a good chance that people think I actually believe this, which is a big problem as far as I'm concerned. There have been really interesting attacks when it comes to this. The possibilities are pretty endless. And so, how do we solve it? It's pretty simple these days. Use web application production grade templating systems at all time. If you're using Jinja, if you're using the Django template system, you're good to go. Interpolation is great, but it's not for this. Another thing is don't DIY your own sanitizers. There are plenty of cases where companies try to roll out their own sanitizers and ran into these issues. It's a little bit more complex problem to solve than people think. It's better to use a time-tested tool for sanitation. Next, there's insecure deserialization. This is a fun one, folks. And so Python has a very convenient pickle protocol. It's great, it's easy to use, and many people don't know that when you bring a pickle to life, it runs the dunder reduce method, allowing for fun things on an attacker behalf, right? So here we have productivity killer, which, once it's going to be awoken, it's going to open a browser to this URL in this case. Now, I should tell you that this is an application I created specifically in order to show you this attack. But there are instances where untrusted stuff, is accepted via the pickle protocol, and then you're extremely susceptible. Basically, the possibilities are endless. Whatever the process can do, the attacker can do. So here we basically accept some data, we decode it using B64 decode. We then pickle.loads that data, and we respond by saying unpickled. Very useful endpoint. Actually, just to demonstrate this, I have decided to run this locally and make my computer vulnerable to myself. I have to exit full screen to show you what my attack script does. So basically, here I am. And let's head over to my terminal. And I'm going to go ahead and run the pickle attack script. And let's see how this is going to take over my computer this time. Okay, so we have two problems here. One, the attacker was able to basically, force my browser to go to this URL. And this really leaves us open to an array of problems. And two, the attacker has made me vulnerable to you guys making fun of my dancing. In this case, the attacker was me. So who would have thought, right? So how do we prevent this? Whenever possible, use other formats. Even though they can be less ideal, they can really spare you some serious issues. Then there is only pickle and unpickle trusted data. This one is iffy. It's not as good as avoiding the pickle protocol when possible. Then there's using components with known vulnerabilities. This happens a lot. I think when it comes to this, the Python community has a slight advantage. We basically have a very comprehensive standard library, so this allows us to not pull components from many places. However, when you pip install something or pip env install, it's a good idea to ask yourself, like, do I really need this package? Would I pay money for this package? Sometimes putting a price to something, like would I pay 10 grand for this, really makes you think twice before cluttering your application with components that could be vulnerable. What can you do proactively to make sure you're not exposed? One package by PyUp that I really like is safety. With a few commands, it gives you a breakdown of where your application stands. I highly encourage you to check it out. Most of the time, you're 2 or 3 updates from safety again, which is wonderful. If you're contemplating installing something or thinking, should I be installing this? You can use this neat tool by Sneak. It's called the Open Source Advisor. You type in a package name, it gives you an overall score of security, but it also breaks it down by how popular the package is, how maintained the package is, how many known vulnerabilities, is there a large community following to it. It's a great empowering tool. I encourage you to use it before you install something and while you're reviewing code. If during a code review you come across something that makes you feel strange as far as security goes, maybe this is a good place to start a conversation about whether this is a good component to add to our stack. Finally, there's insufficient logging and monitoring. A lot of times attackers hang out for a really long time before doing damage and no one notices. This is tragic, and often this can be prevented by looking for abnormal behavior when putting together, logs. And so when we're doing design reviews, if we have a DR template, maybe we should add a section in the template for, defensive logging and looking for abnormal behavior. But it's also about constantly thinking, how would I notice somebody exploiting this over time? Am I keeping track of people who are trying to credential stuff? Am I keeping track of people who are tampering with cookies? These things can really give you a heads up. If you're using the Django admin, a lot of people replace the Django admin URL, but keep the admin URL active and basically keep tabs of whether people are trying to exploit the admin site, keeping track of those IPs as well. And so if we think about kind of an overall solution to a lot of these, we can look at this chart. And this chart is not about application security. I think it's about organ donation. And it shows us how when you have to opt out of organ donation, pretty much almost everyone donates organs. If you have to opt in, almost no one donates organs. And so I think that secure features should be ones that you opt out of. By default, we should be using tools that escape XSS. By default, we should be configured securely, and that's how we achieve robustness. And so I guess the solution is to use and come up with tools that allow us to stay lazy, productive, without compromising security. So what's next? And this is my total shameless plug. I'm sorry for it. The folks at LinkedIn and I have put together a course that goes comprehensively into the process of securing applications with hands-on examples, and we work through how to secure numerous applications in the more popular frameworks in Python. This might be something that can help you and your team secure your application, so I encourage you to check it out. If you have any questions regarding it, feel free to ask me. I'm also pretty responsive to students asking questions on the forum in this course. I think by now we've reached well over 4,000 learners from pretty impressive companies, and I'm very glad that feedback has been great. And I guess I wanted to really thank you for joining me, for taking the time to think more about security. I really, really want to thank the organizers of this event for putting in incredible amounts of work to make this happen. Thank you so much. So thank you. Be kind, be safe, and I will see you shortly in the breakout session.